Hi all. We'll discuss about battery technology today. It's part of engineering chemistry syllabus unit 2. You all know that the battery is something like which you cannot even think a day without the use of battery. Whichever the electronic gadgets which we are using, which we come across, everything needs a power source. Let it be a calculator, let it be your mobile phone, let it be your laptop, let it be electric vehicle. All these things are powered by a battery. So here in this unit, we are going to see what are batteries, what are different components of a battery, how a battery works during discharging, how a battery works during charging, and specifically we will try to take one typical lithium ion battery which is very commonly which we see in almost all the electronic gadgets. That also we will discuss in detail. Okay, so like how what you're seeing in front of you, you can see this the application of the battery is very huge, starting from a small earbud or a pacemaker or a huge car or a laptop or a electric vehicle, everything, it needs a power source. So we are going to learn about that battery technology, which has revolutionized the electronic industry. By reducing the size of the battery, we were able to reduce the size of the product itself. Okay, let's see what we can learn from this unit. Okay, fine. We all know that this is a simple conventional definition given to a battery. We all know it is an electrochemical device. So we have learned what is electrochemistry or what is electrochemical reactions. When one form of energy is converted to another form of energy, it will be electrical energy to chemical energy or chemical energy to electrical energy. We call such reactions electrochemical reactions. Okay, so the battery is a simple electrochemical device in which electrochemical cells are connected in series, that it can be used as a source of direct electric current at a constant voltage. Simply, if you want more power, we'll come to that. If you want more power, we need to connect different batteries, because when we study the working of a battery, we'll have a complete picture of why the batteries are connected in series. Huge batteries are connected in series to draw more power. Okay, so these are used, as I told, it has revolutionized almost all electronic systems. So it has created a new era of transportation. With we have replaced the petrol driven automobiles by the electrically powered ones. So I should have some knowledge about batteries, and let me tell you, the immense research is going through this field to develop or to increase the efficiency or develop new alternate materials for better power output. Okay, these are different conventional batteries which comes to our mind when we hear about battery. These are the batteries which comes to your mind, right? Which a simple cell, which a device which is convert chemical energy into electrical energy. So if you want more, we'll combine this. That's 9-volt battery, 6-volt drive. How much power it can give. That also that also makes the size of that battery. Okay, so if you want more, we want to have more materials inside. So we'll see what are the developments happened in battery technology during last so many years. You can see huge batteries which is stacked to get more power. You can see this type of batteries are used for huge. If you want more power, you need big batteries which can be placed like this and connected in series to draw the power. Okay, just to show you, just to get an idea. And see this, This is not a battery yard. It's not a battery yard. It's a place where we are drawing power to power a huge industry. How they are using, see the batteries which is kept. So the size of the batteries, it ranges from a fraction of cubic centimeter to several cubic decimeters. So you can imagine, if you want more power, you need to have more batteries. Yeah. Coming to, we should know battery. When we are talking about battery, we should know the basic components of a battery. As we all know, any electrochemical device, it will be having an anode, it will be having a cathode, it will have an electrolyte, will have an anode active materials and cathode active materials, or active materials and inactive materials. So during discharging, these active materials convert to electrochemical inactive materials, and during charging, it converts back to electroactive materials. So these are the simple components of a battery. We have an anode, we have a cathode, we have a separator, we have electrolyte, we have active materials, anode active materials, and cathode active materials. How a simple battery works? You know, it's all simple things. Just to recollect, or just to recollect the things what you have learned in the lower classes, I'm trying to give a brief introduction about this working of battery. So when an anode and cathode, when we are connected through a load, what happens? It leads to a spontaneous reaction. Oxidation reduction happens. So the materials which takes parts in this this spontaneous reactions, we call it as electroactive materials. So you can see the electrons moves from anode to cathode, and the current flows in the opposite direction. Correct. So the intensity or the vigorous way of the reaction happens, it leads to how vigorously the reaction happens, it leads to more power generation. So point to be noted here, it's very simple, which is a material which takes parts in spontaneous reaction, we call it as electroactive materials. Okay. Before going into depth, we'll just simply see some of the simple classification of batteries. We are classified into primary batteries, secondary batteries, and the reserve batteries. Okay, it's very simple. Primary, which cannot be recharged. Secondary means you can reverse the reaction and recharge the batteries. That means if you supply the DC current, it can be charged back. The electro-inactive materials can be converted back to electroactive materials. So simple example, the lead acid battery. All the huge vehicles, what you see, if you take a bus or a car, we use the simple lead acid batteries in that. So it's in a simple example. So when you drive the car, it is recharging the battery, right? So this type of batteries you call secondary batteries, and which cannot be, which after the usage, when you throw it out, we call it as primary batteries. Or example is our simple dry cell. Okay, the third category you should know, it's maybe you must not have heard about it. It's reserve batteries. So here, what is it? Some component is kept as a reserve. So these are batteries when it is inactive, when not in use. Okay, so we can activate it in different ways. When we need something, we can activate it. So this is a battery which exists without a vital component. If you want to take the power from it, if you want to make it, if you want to activate it, it will add this component and make it activate. For example, we have silver chloride cell here, where we are see that the seawater, what we are using, it is a component which is missing in this. So when we want this, we add that and we activate these batteries, like magnesium battery. Point to be noted. It is one component will be missing. That component, prior to requirement, we will activate it or we'll add it and make it active. Okay, so there are different types. We have electrolyte activated batteries, heat activated batteries, and gas activated batteries. So just keep it in mind, three classification: primary batteries, secondary batteries, and reserve batteries. Yeah. I have told what is this primary battery. Just when we see this, we have some nostalgic feeling. I don't know, this type of batteries. Still, it's available in the market. Yeah, this is a secondary batteries, as I told, which we can use it in vehicles. If you simply open your bonnet of your car, you can see this type of batteries which is there inside. It is a simple example of secondary cells or secondary batteries. So what happens during a battery operation? So during discharging means when we want to take out the power, which is, or if you want to convert an electroactive materials to electro-inactive materials during the discharging, this is a process of what it happens. Electroactive materials which is stored or which takes part in the spontaneous reaction converts to electro-inactive materials during the discharge. So as I told, oxidation takes place at the anode and reduction takes place at the cathode. Here the chemical energy is converted into electrical energy. Simple example is lead acid battery. And what happens during charging? The reverse reaction happens. So this reverse reaction will be non-spontaneous in nature. Obviously, how we bring this reverse reaction? By connecting to an external direct current, DC power supply. Okay, so the batteries which can reverse, such batteries we call it as secondary battery. So this is a simple chemical reaction, simple chemistry happening when during the operation of a battery. Okay, we'll go to the next slide. Yeah, you can see there's a simple discharging. You can see at anode, the metal undergoes oxidation. The electrons are liberated. The electrons move through the external circuit, and thus it is accepted by the cathode, which accept these electrons and undergo reduction. So during this reaction or oxidation reduction reaction, the electroactive materials are converted into an electro-inactive materials. Okay, so this process is known as discharging. So EMF or cell potential, cell current, what we are getting, it decreases during discharging process. It decreases during discharging process. So same recharging, what happens? The reverse of that. So we are supplying an DC current. So here electro-inactive materials, we are converting back to electromaterials by passing current or passing electricity in the opposite direction. Okay, so if you can pass the current in opposite direction, you can recharge the battery. That's what happens when in our same way we keep it for charging when a battery drains. So we'll see whether frequent charging is good or not. Some people are like, you may see that they'll keep on charging at when it comes to 90%, again they'll make it to 100%. Is it necessary? We'll look into it. See, so during charging, during the charging, the EMF of the cell which gradually increases and reaches its initial value, as I told. Okay, so our yeah. Now we have what we have seen for last couple of minutes is what is a battery, what are the different components of a battery, how a battery works. Okay, since our syllabus demands lithium, the discussion on lithium batteries, now we will focus on lithium batteries. Why people have preferred or crazy behind this lithium batteries? Simple, lithium was the lightest of the metal. It's highly reactive. So there's one question you can expect here. Why aqueous electrolytes are not preferred in lithium batteries? Because of lithium is very reactive. Okay, so these are the properties which given lithium a very high potential to achieve this high energy density and power density. Here we use lithium metal as an anode in lithium batteries. We'll see which are the different types of lithium batteries we have. When you classify this lithium battery, we have two types. We have lithium metal batteries and we have lithium ion batteries. Okay, we are more focusing on lithium ion batteries because the syllabus we are supposed to discuss about lithium ion batteries. Okay, so this lithium metal, basically it is a primary batteries which cannot be recharged. Whereas secondary lithium ion batteries are as the ion batteries which we use in our laptops, mobile phones, everywhere in our watch, everything we use lithium ion batteries. So we can recharge these batteries. These are considered as a secondary batteries. Okay, can we move forward? Okay. So what are the characteristics of a battery or lithium battery? It's having high energy density, obviously high voltage, no memory effect. It's have a very stable power. That means flat discharge voltage is observed. Low self-discharge, it will not get discharged. If it's not kept in use, the self-discharge, it's very less compared to nickel batteries, nickel cadmium batteries. So here in lithium ion batteries, we use lithium cobalt oxide as a cathode and specialty carbon as a negative. We are going to discuss in detail about lithium ion batteries. Okay, let's see. So just one point which I want to make, this is the core point which you should keep it in mind. In all lithium batteries, there is simple migration of lithium ions between this positive and negative electrodes. So there is no chemical changes which you are observing in two electrons. Okay, let's see. Lithium ion battery. So we'll discuss about lithium ion battery in detail now. How we can construct a lithium ion battery? The anode used in lithium ion battery is lithium metal, which was dissolved into a carbon. We have a cathode. So cathode is made up from compounds which can liberate lithium. Typically, we use 3 electroactive oxide materials. We have lithium cobalt oxide, manganese oxide, and lithium nickel oxide. So any of this material you can prefer for the cathode material. So point to be remembered. Okay, you should know if you know what is an anode. I mean, which is an anode, which is a cathode, which is electrolyte used. Okay, so the electrolytes we prefer lithium salts like LiPF6, LiBF4, which are dissolved in an organic solvent. Solvent means which is mixed in propylene carbonate or ethylene carbonate solvent. Okay, this I told we cannot use aqueous electrolytes. That's why we are using, as I told, that lithium is highly reactive. So basically, the electrolyte should help, whichever electrolyte you're using, it should be help in conduction of lithium ions to cathode during the discharge process. So here, ionic conductivity happens rather than electron conduction. Okay, we'll use a separator also here. A fine porous polymer film is used as the separator. Yeah, this is a simple, you can see. I will explain the working. So as I told, this is a simple movement of lithium ions between two electrodes. We have a positive electrode and we have a negative electrode, where we are making use of the movement of ions for generation of power or electricity. How it is done, we'll see the reactions which happens in lithium ion batteries. Yeah, we'll see the working of lithium ion batteries, or the reactions that takes place inside the battery during the charging and discharging operations. So we'll see if you have a simple battery with you in a lithium ion battery, a battery which you are using in your laptop or in your mobile phones. So what happens at anode? See, with the lithium ions gets oxidized. Where is this lithium ion present? The lithium ions present in the graphite layer will get oxidized. So once it gets oxidized, automatically, you know, the electrons, what it will do? It will jump out of the anode and it will move towards cathode through the external circuit. Whereas this lithium ions, what it will do? It flow through the organic electrolyte and reaches towards and move towards the cathode. Are you getting my point? When they reach there, what happens? So the electrons are moving through the circuit, external circuit, from anode to cathode. The lithium ions are moving through the electrolyte. So simultaneously, what happens at cathode? The lithium ions, have been reduced to lithium. And what happened? It getting inserted into the layered structure of the metal oxide. You can see the reaction which is given here. XLi plus X electron plus L 1 my X CO2 gives lithium cobalt oxide. So the vacant sites, what it is there, it get inserted, lithium get inserted into this layered structure of the metal oxide. So lithium moves from anode to cathode through the electrolyte, and the electrons which flows from anode to cathode, it reaches cathode, and these electrons are received by the lithium ions and get reduced to lithium, and these are inserted into the layered structure. So you can see this happens during discharging. During charging, what happens? This inserted lithium will undergo oxidation and it will go back. So this is what happens in a lithium ion battery. We'll see. So this is a simple reaction what happens during discharging. Now what happens? This will be continuous charging and discharging cycle is repeating, right? So during charging, what happens? So the lithium ions which are gone and sat in the layered structure of lithium cobalt oxide, it will get oxidized and liberate electrons. The electrons move through the circuit. At anode, what happens? These ions, which are, lithium ions are reduced to Li. How? By accepting the electrons which is coming from the other electron. So simple reverse reaction of discharging happens during charging. So the movement, the ions which is responsible for this, it is lithium ions. Lithium during discharging or charging, this lithium ions are moving between two electrodes. That's why I told in the beginning, lithium ions are involved in the movement of lithium ions are involved in this lithium ion batteries. Okay. So these are some of the advantages. Just I have told again, it's less weight, better high energy density. Only one disadvantage what you can observe in lithium ion batteries are they're a little bit expensive. Okay, it have better improved safety than the other batteries. We'll see, and we have some videos also to animation to show you the working of lithium ion batteries. So it's huge applications are observed for this lithium ion batteries. As I told, cardiac pacemakers, implants, what we use, all telecommunication devices, everything. Aerospace application, everywhere we can use this lithium ion batteries. We should always reuse and always try to be how we can do that. So obviously rechargeable batteries are best options for us. Just I'll show you, I'm showing the different ways of how the lithium ion batteries works. Same reactions. Yeah. We'll see how it works. Okay. Can you see this? During discharging now. What happens during discharging? See, I'll play this animation. See, slowly the lithium ions are moving through the electrolyte. Electrons are moving through the external circuit and reaching and going and sitting between the layers of lithium metal oxide. See? Thank you for watching.